The sum of the forces acting on a body are equal to the rate of change of momentum on that body. Newton's second law gives us a way of quantifying force through a measure we have come across before. Firstly, we should discuss momentum. Momentum is the mass of an object multiplied by its velocity. It is here that we see why you treat forces like vectors. A mass is a scalar term. The value either goes up or down. There is no direction associated with mass. In the same way, there is no direction associated with charge or colour. Mass is a property of a material, therefore it belongs with that material. It is not separate from it, and so cannot go anywhere. Velocity, however, does have a direction associated with it. When you multiply one by the other, you end up with a vector. A magnitude multiplied by a magnitude in a direction still contains a direction. As velocity is a vector quantity, then momentum must also be a vector. This means that we can add them together as we have done with other vectors. Momentum is a useful term to describe the willingness of an object to move. A large mass does not want to move. You would need to apply a large force to move a large mass. If you wanted to make that same mass move more quickly, you would have to add an even greater force. This is the essence of Newton's second law. When you change an object's momentum, you are essentially changing its velocity. The object's mass doesn't change, so it is simply the object's velocity that does. It is possible to change an object's mass. If it were to explode, or be involved in a collision where mass was added to it, then the mass of the object would change. However, we will not concern ourselves with it at the moment. For now, the mass stays the same. If the mass stays the same, then the force applied to an object is dependent on a change in velocity. If you were to make an object change velocity rapidly, you would require a large force. If you were to make the same object change velocity slowly, you would require a smaller force. However, in both situations, the momentum change would be the same. In one situation, you are changing from one velocity to another. In the second situation, you are doing the same thing. The momentum change is the same. However, what has made the system require a greater force is the rate at which you change velocity. The rate at which you change velocity has another name that we've come across already in previous podcasts. When you change velocity, you do just that. You change velocity. When you change velocity quickly as opposed to slowly, then you have an increased acceleration. The rate of change of velocity is acceleration. This means that we can state the sum of the forces of an object, worked out by adding vectors, etc., to be the same as the mass of the object multiplied by the acceleration of the object when subjected to the sum of the forces. This only occurs when the mass of the object stays the same. If the mass changes, then we must use our original definition of the second law involving momentum, as this has masses inside of it, and allows us to determine the velocity associated with each mass. For now, you know that if the mass stays the same, you can measure the overall force on an object by multiplying the mass of the object by its acceleration. In this way, you can determine the forces acting on a system by looking at how quickly an object moves and changes its motion. These are easily measurable.